Okay, this is from IBC calculus class. So, the topic is what is calculus. This is a very huge and very broad topic, so I try to make it in within 10 minutes. For me, to me, is what mean by calculus. So I disagree of a lot of article writing to respond to this question. All due respect, just my own opinion. Okay, I read article, people say calculus is a rate of change, conversing like this, like that, but to me, limit is a tool to carry calculus in the perfection. And calculus study the rate of change. Calculus is not the rate of change. And a whole lot of things people saying calculus is this, but actually people saying how wonderful calculus is. I try to express, from my opinion, what is calculus. Okay, so I won't tell you, but only one single word. Later on, I don't depend on student, whatever you think, what I'm trying to say. Okay, first of all, calculus exists like many thousand years ago. Okay, the concept calculus exists many hundreds thousand years ago. So therefore, Newton, the fundamental calculus is not calculus. That is a discovery to carry the concept of calculus into a perfection. For example, in the past, calculus, when you find the area under the curve, I make something simple, x squared from 0 to 2, right? So in Newton say from 0 to 2, x squared dx equal blah blah blah. Okay, so that is the discovery of fundamental calculus to get the perfection, but actually the day calculus we don't know. We just approximate the area within the reasonable error. Okay, so let's start this way. People trying to find the area of a circle, right? There's no pi, nothing. We don't know anything about that. Okay, we just try to estimate the area of circle. So what people do is people divide this one, by 4. So then people trying to install a square inside this. Okay. So now, even you have a circle without a center, we still can use the compass construction to find the center, right? And we can prove it why it should be the center. So the square here, so if we have the radius, the circle equal radius from here to here, so this one should be r root of 2, right? Because this is 45, 90 degrees. So the length of the square of the small inscribed square is the length is equal r root of 2. Therefore, the area of the square equal r root of 2 square, right? So then they circumscribe the circle with another square. So right here. So therefore, the length here had to be 2r, right? Because this one radius, 2 radius. So the area of the bigger square is 2r square. You add them together and you take the average. Okay, so you have 4r square plus 2r square divided by 2, you have 3r square. So you take a look. So this one here we know now is pi r square is the area of the circle, right? With the radius r. You see it's very close in terms of in the past, the life is so simple, and between 3 and pi almost the same. See that? Only this one calculus. Okay, calculus not about to find the answer. Calculus about trying to estimate the answer within certain error. Certain error, and error should be small. So now how to make it error smaller? So very simple. People, instead of this, they divide by 8, for example, or you divide by 6. But let's thinking about if you divide by 8, what happened? So you have like this. Okay, you have like this. And now you install the octagon, right? Octagon. Okay, so the octagon should look like this. You have 8 triangle. Okay, you have 8 triangle. So then you find the area of each of them and you multiply by 8, right? So now if you do this, so the area become only this, and you don't need to outside if you keep dividing like 16, right? So you see when you divide by more triangle, this one is this one is called hexagon, octagon. So the area shrinking into like this. But how about divide by 16? So go like this, so you go like this, and you go 16 triangle here, associate triangle here. So you go like this, and you go like this. Okay, go like this, and you keep divide by 16 of this. Okay, divide by 16 of this. And you divide by 16, then you can see the area now is become very small, right? Very small. How about if you divide by 160 or even 1,000? So all this one here is shrinking into 0. So what the procedure we call you exhausting the area, okay? The method of exhaustion. So how about this? Okay, so in the past people keep doing this to try to find the area of circle in a very, very accurate, like accurate to like 5 decimal from this formula. Many years later on, people found it, right? So now later on, what happened is this. So let me show you how people find the area of the rectangle, of the circle. So now in this case, people start to arbitrarily you divide by n triangle. So let's say that means n polygon, right? You have n polygon. So you divide by n. So let me do one of this look like this. One triangle look like this. Okay. So you have many of them, but I draw this to see. So this one here, if you divide by n triangle, so the angle here has to be 2 pi divided by n, right? Right? You divide by n can be 100, 1,000, a million, whatever. 2 pi divided by n. And we try to find the area of each of these and multiply by n, right? So then if n getting large, so this one here is going to be 0. If n getting like 1,000, a million, a trillion. So this one method of exhaustion tells us that this one shrinking 0. If n keep growing, in this case, if n goes 16, you see the error very little right here. Very little right here. You have 16 error, right? If you divide by 32, the error shrinking dramatically. So now let's say in general I divide by n. So I try to find the area of this triangle here, and I multiply by n, and I make n go to infinity. Then I should be able to find the area of the circle. So let's take a look here. You divide this by 2 to make the right triangle. So this half of this must be pi over n, right? The angle should be pi over n. And the radius equal r. So now the area of triangle equal 1/2 of the base times the height. So now what about 1/2 of the base is this one? This one the base, 1/2 is this one. But in trigonometry, this one should be r sine of pi over n. So the line here, because sine of pi over n equal the opposite over r, therefore the opposite equal r times pi over n. How about the height here? The height here is r cosine of pi over n. Okay? So now I write the area of one of the triangle here equal 1/2 of the base, which is r sine pi over n. So which is r sine of pi over n. That is half of the base. This is the base, this is half of the base, times the height, times it r cosine of pi over n. So I have one triangle. Then I multiply by n of them. right? I multiply n of them. Then I take a limit and go to infinity. Then I should have the area of the circle correctly, accurately. So how to do with this? So first of all, I go n here. So r square, r times r square here, sine of pi over n, okay, time with cosine pi over n. Then I take a limit and go to infinity. So I need to get rid of this. Okay, so if n goes to infinity, so I need pi over n because in the bottom here. Why? Because we know that the limit sine of theta over theta goes 0 equal 1. The same thing here, limit sine of pi over n go to infinity. If n goes to infinity, the whole thing goes to 0. The same thing here. The whole thing goes to 0. Same thing with n goes to infinity. So that's equivalent. So now when I take n, this piece here becomes 1. Right? And I put infinity right here. So this cosine, but when I multiply this one by pi of n, I have to multiply everything by pi of n as well. So balancing, right? Original right here, I multiply the bottom by pi of n, I have to multiply to the numerator pi of n as well. So this one is going to be 1. And if infinity times this, pi divided by infinity equals 0. So cosine 0 equals 1. So I have 1 here times 1 here. So I cancel that n here. So finally I have the area equal pi r square, which is, we know now, is area of the circle with radius r. Okay, that is the beginning. So now let me take a little bit more. So this one here is calculus. You take n equal 100, still calculus. N equal 1,000, a million, that calculus. To try to find out as close as possible the value of the area of the circle with radius r. The limit here is not calculus. The limit is the tool that we discover after calculus concept. So carry this one into the perfection. So therefore limit is not calculus. Just a tool developed later on to carry the concept calculus into the perfection.